buying houses. Okay, so today we're gonna do parts of the problems because, especially number three, um, it has us do this scenario where it wants us to find out how much money we would have to pay if we wanted to pay out the house in full. Like if we try to pay it off like 15 years later after you bought it, and then you wanted to just pay off the rest after those 15 years. But it requires doing like this really long spreadsheet that has like 240 different entries, 240 different rows. So we're not going to do that. So we're just going to do parts of number three. We'll do parts of number four, and then we'll do parts of number six as well. Okay, so we should be able to get through those next three problems today. Okay. All right. So between 2008 and 2012, the home interest rates dropped dramatically. Okay, that was true. Okay, that happened because right after the mortgage crisis, people weren't buying homes. So then, in order to give people incentives to buy homes, the interest rates were lowered. Okay, on January 15th, 2000, okay, the Lopez family took out a 20-year mortgage for $150,000 with monthly payments at an APR of 6.5%. Okay, so we're looking at 20-year loan at a 6.5%. Assuming that the Lopez's make the monthly payments each month, calculate the unpaid balance of the mortgage on March 15th, 2000. Okay, so if they bought in January, let me highlight here. If they bought on January 15, 2020 or 2000, they want to know how much is owed after basically just 2 months, right? So we'd have to calculate just two different payments and see what's left that they still have to pay. Okay. So we need a little bit of background information in order to build this. So remember that whenever you're given the year, the 20-year mortgage, and you're given the APR, this is going to tell you how many dollars you are paying per the 1,000 borrowed. So we have to go back to that table from the very beginning. So let's go back. Okay, and we're looking at, let me erase some of these. We're looking at a 20-year, 6.5% interest. So they are paying $7.46 for every 1,000 borrowed, right? So then in this case, for us, because it was a mortgage of 150,000, first we have to find out what those monthly payments are going to be. Okay, I already forgot what the payment was. 746. Okay, so we have 746. Okay, but remember, in order to find out that monthly payment, we multiply that times 150,000 divided by 1,000. Okay, so what happens here, right? 1,000 goes into 150,000, 150 times, right? So really what we're looking at is 7.46 times 150. That's going to tell us our monthly payment, right? So let's go ahead and find out what that's going to be. 7.46 times 150. And it looks like we get a monthly payment of $11.19. Okay, so here's our monthly payments. Okay, so we first have to find out how much they're paying monthly so that then we can start to deduct or subtract what is owed month after month. Okay, now remember that when we take out a loan, part of the monthly payment goes to pay interest and then a small percentage goes to pay the balance. So not all of this money is going to go directly to the balance, all right? We have to find out how much interest is being charged so that then we can then subtract from that, and then that's going to leave us the true balance. Okay, so we know the monthly payment. Now what comes next is find out, well, how much interest is that person paying that first month? Okay, so one of the ways in which we can find that is we can take 150,000 because this is at the very beginning, right? So this is what they owe. The interest that is being charged, how do I explain this? We're going to add that on to the 150,000 so that we know exactly what interest had been added to the balance or to the loan of the home, and then we subtract the monthly payment. Okay, so here's what I'm going to do. I'm going to take this, I'm going to do 1 plus. Okay, the reason why I'm doing that is because if all I did right now was just to start with the interest, and the interest in this case was 6.5%, so if I rounded it to 0.065, and because it's monthly payments, you divide this by 12. If I were to do this calculation, all it tells me is what the interest is on this amount for that 1 month. Okay, but I don't really want to do that and then step after step. I just want to know if the interest is then taken into account and then added onto the 150,000, what is it that I'm actually paying for, right? So I'm just going to put in here 1 plus. Okay, and it looks kind of similar to the compound interest formula, because that is essentially what it is. Okay, so this is going to help us and give us exactly what is owed, right? Once that loan starts, interest starts building on the 150,000. So the interest that is generated on that first month, it's added on to 150,000, and then when you do your payment, some of the money goes to knock the interest down, and then the remaining amount is what goes to the balance. Okay, so what we see here is, let me find out what 0.065 divided by 12 would be. Okay, so that's that's not a very friendly number, so let's just go ahead and add 1 to that. And then we want to multiply this by 150,000. Okay, so then this results in 150,812 with 50 cents, right? So interest has now kicked in, right? So for that first month already, right? Look at how much interest it is that you're going to pay for that first month of your home. It's going to be $812.50. So now from here, you can then say, okay, now I can pay my monthly payment. My monthly payment is going to then subtract 100 or $1,019. Get rid of this dollar sign. Okay, and then that's going to leave us with whatever is left over to pay in the month of February. Okay, so let's go ahead and do that. Now we can subtract 1119. Okay, so all of the money that you paid, do you see how it's going to knock off the interest, and then the remaining amount is what's then just going to go into your balance. So then what's happening is that you can see that what you owe for the month of February is going to be 149,693. Okay, so it didn't, your 1,119 monthly payment doesn't go directly to the balance, right? Every month it's going to generate how much interest do you owe. It's going to add that back onto it, and then when you take your monthly payment, it's going to subtract. So it's going to take the interest away, and then whatever's left over, that's what actually goes to the balance, right? So that's why it's such a slow process on paying off a house, because you're not just paying off the house, you're paying off the interest. And that's what makes paying a house take so long sometimes, and what makes it so expensive. All right, so this is now our balance for the month of February, right? So here's our balance, February 15. Whoops. 2020. Okay, but they want us to find out not the February balance, but the March balance. Okay, what is the balance? So we have to do this one more time, right? So we run this one more time with a new starting balance of 149,693 with 50 cents. Okay, we're gonna have to find out what is the cost, or what is the balance gonna go back up to when the interest is calculated. So we go ahead and multiply here by 1 plus the same rate, 0.065 over 12. Okay, so let's go ahead and do that. Hold on, I'm trying to put it somewhere. I can see. Okay, so we have our value there. We can go ahead and let me start with the 0.065 over 12. Add 1, and we multiply now times 149,693 with 50 cents. Okay, so now you see the interest has now caused your remaining balance to move back up above 150,000. So what you're looking at now is 150,504 with 34 cents. Okay. So interest kicks in, moves you back up to 150,504 with 34 cents, and now you make a monthly payment, right? So you make a monthly payment, same monthly payment of 1,119, and now you have a new balance of, let's find out. Okay, 149,385 with 34 cents. Okay, so you're making some small progress there. Okay, but then now this represents here what your balance will be as of March 15, 20, or 2000. This should be 2000, not 2020. Okay, does that make sense so far? Why I've been using the 1 plus inside of the parentheses? It's so that it tells me what the true total balance will be. If I would have done just 0.065 over 12, it just gives me the number of how much interest is um is added, but it doesn't, then I would have to do the adding myself. So if I just put 1 plus in there, it tells me, well, you keep the balance that you have and you're going to add whatever interest onto it. Okay. And now that leaves you with the total you can subtract your monthly payment from it. Hmm. Hold on, I got something a little different from the book. Maybe I made a mistake here. Let me try this one more time. 0.065 over 12 plus 1 times 149,693 cents, 150,504, and then minus. No, I'm good. Yeah, I'm good. I guess the book, there was a typo there. Okay. All right. So any questions on that so far? This is how the monthly payments affect your balance, right? So if you get a statement, typically you get statements when you make monthly payments for your home. Same thing as with the credit card. You're gonna see like, okay, I'm sending these big payments. I'm not making much of a dent to my true balance, to what I truly owe to my house. And the reason why is because that interest is heavy, right? Just look at the first month. You went from 150,000 to 150,812, right? So this amount right here, imagine you have to pay all of that off before you can apply any money to the true balance of the house. So then what happens is once you take $812 out of the 1,119, there's really only what, like $300 left. So then you get to apply just $300 to the actual house. Meanwhile, the bank is collecting $812, and that's how banks make so much money off of home loans, right? You wouldn't think because of the interest. 6.5% doesn't seem like a huge interest, but when the total value of something, 150,000, and you're taking 6% of that, it becomes kind of heavy, right? So that's the underlying area where banks make tons of profit just from making home loans. Okay. All right. So then if we looked at the next one, part B, this is what I'm going to skip because it's asking us to find the unpaid balance of the mortgage on January 1st, 2001. And that's just a very tedious process because we would have to do it 10 more times, right? We already found the balance for February and March of the same year. We'd have to go all the way to January of the following year, right? So we're not going to do that. It's going to take a little too long, but it's the same process, right? You just take that new balance. That's what you multiply by 1 plus 0.065 over 12. You subtract your monthly payment, and then you do it again and again and again and again, right? So it's a recursive process, but we're going to skip it, okay? And then the question after that is asking us here, given the comparatively high interest rate, which it is, 6.5% is a pretty high interest rate for a home. Okay, they have decided to continue to make their monthly payments and additionally save and make a lump sum payment on January 15, 2015, right? So they've been making regular payments for 15 years. Remember, it's only a 20-year loan, but for 15 years, they've been making the regular payment. And they've decided, you know what? On January 15, 2015, we're going to send a lump sum, which means we're just going to pay off the rest of the home all at one shot, right? To save us 5 years of monthly payments. Not only 5 years of monthly payments, but 5 years of having to pay interest, right? So that's the benefit of if I can just pay off my home quicker, I save a lot of money on interest. Okay, so to complete payment on the mortgage, all right, what is the amount of the lump sum payment that must be made? How much money in interest does the Lopez family save? Okay, so in order to do that, we would have to know how much is owed on January 15, 2015. Right now, imagine if it takes us having to do this 12 times for 1 year, well, we'd have to do it 12 times 15 to get up to 15 years. So again, we're not going to do that. That's just going to take too long. Okay, but it is possible for us to do it this way. There's also a spreadsheet that we could have done. And again, if we were in class, we could probably take the day and spend a day learning how to do some spreadsheet stuff. But we're not going to do that right now. Okay, so just know that there is a way to do it with the recursive process that we've started. We're just not going to do it because it's going to take too long. Okay. All right. So with that said, let's move on to number 4. Okay. All right. So for number 4, we're looking at something here where we have a person named Josh who starts to see some sort of pattern in problem 3. Right, so Josh sensed that the underlying structure of finding the mortgage balance owed after 15 years by the Lopez family was similar to finding the future value of an investment with an APR compounded monthly that included a fixed monthly deposit. This is what we learned maybe about like 2-3 weeks ago, right? When we looked at what is my future value? What am I going to get in the future if I invest this much now and then every month I keep investing, let's say $400 or $500, right, at a certain rate, okay? What is it going to be in, let's say, 15 years? So what they're trying to tell us here is that there's a similar way to find that amount using a formula that we've already seen, okay? So let's just kind of keep reading here. So since this approach was quite different than the approach taken by his group, Josh decided to test his thinking at home, yada, yada. Okay. So explain and discuss the soundness of Josh's thinking as described below. So here's what he's thinking. It seems like finding the balance owed on a mortgage in the future is like finding the future value of an investment or savings account with regular deposits of a fixed amount. Okay, so he's saying if I want to know how much I owe on a mortgage after X amount of years, it's a very similar process in terms of finding out what that is if I use this formula like the future value of an investment, right? Where the first part of this formula tells you how much you invested at the beginning, right? And how much you're going to earn based on that initial investment, but it also considers how much money you're going to earn on that interest when you make monthly payments, right? So we got to the point where we knew that and let me highlight it, I right here was your initial investment, and then A was the recurring investment, right? So if I put down 1,000 into an account, it's going to start to earn some interest, compounded monthly, right? Assumption that it's compounded monthly. And then every other month after that, I put in $300, right? So then those $300 are going to earn me some interest on a monthly basis. And then I'm going to be able to pull that all together and say that in the future, this is what I will expect to have, okay? So he's saying that there's a similarity there, right? Because with a home, maybe what you've done is that you've put down, this is what you're borrowing, right? And then after each month, you can subtract from that. Maybe it's the opposite, right? Rather than adding up, you're subtracting from it because you are making those monthly payments, right? So the A value is kind of like your monthly payment, but instead of it going into the account, you're paying it to subtract and reduce the size of your balance. Okay, so here's kind of what his thought process is. He said, could I use the formula to find the future balance on a mortgage by subtracting the expression representing the monthly savings contribution? So what he's thinking is, let me change this formula by, instead of having a plus, let me change it to a minus instead. Because what I'm doing is I'm subtracting away from the initial purchase price of the home, right? And not only is it subtracting away from that, but it's taking into account all of this interest, all this background interest that's happening, right? So that's why we have so much information inside of those parentheses. So he's saying, I was thinking the expression A times the rest, right, as the sum of the monthly payments for T years. That should work if the first expression represents the cost of the mortgage for T years. Okay, so really what he's going to try to do here is, let me just kind of change the formula a little bit. Let me just change it from an addition to subtraction. And let's see if this actually gives me something that could work to determine how much I owe after, let's say, 20 years or 15 years. Okay, now how could that be helpful to us is because remember that we skipped that part of the problem in number 3 because we didn't want to have to do this 12 times per year for 15 years, right? That's going to take too long. So maybe if we use his formula, it can help us find how much he's going to owe on that given date. All we have to do is use the same formula, but change it to subtraction instead. Okay, so that's kind of where we're headed to. So using Josh's idea, how much interest could be saved by paying off the 20-year mortgage as a lump sum on January 15th, 2015. Okay, so the question is kind of loaded. It's asking how much interest could be saved by paying off the 20-year mortgage as a lump sum of this amount. Okay, well, first off, what we want to do here is, well, let's see what he would have to pay off on that date, right? Assuming we're using his formula here. So what we want is F. I'm going to make this a function of time, right? So my final value given time will be I times 1 plus R over 12 to the 12 times T. But this time we're going to subtract those monthly payments. So that's A times 1 plus R over 12 to the 12 times T minus 1 all over R over 12. Okay. All right, so now we can go ahead and plug in some information. We want to know how much interest he would be saving if he paid it off on January 15, 2015. So 2015 is 15 years after he initially bought the house. So we want to know what is it that I owe 15 years later. So we use that into our formula, so that time is going to be 15 years. So F of 15, right? So my final value at 15 years, how much do I owe after 15 years, is going to be calculated with my initial. My initial is how much you are paying for that home, right? So if you are initially paying 150,000, then that's your initial. Okay, 1 plus the rate is 0.065, still the same APR over 12. And then to the 12 times 15, right? Because we're using 15 as our number of years. Okay, minus, this is what we're going to subtract, minus A. A is the monthly of recurring payments. So every month we know that we're paying that 1,119. And we have 1 plus rate 0.065. Over 12 to the 12 times 15 minus 1 all over 0.065 over 12. Okay, so this is going to help us find out how much do these people owe on their house. What is the remaining balance after 15 years of these consecutive monthly payments. Okay, so let's go ahead and find out here. I'm gonna go to Desmos. Okay, so we start with 150,000 times 1 plus 0.065 divided by 12. And then this goes to the 12 times 15th power. But we're going to subtract from that 1,119 to the 1 plus 0.065 over 12 to the 12 times 15 minus 1. And then this is all over. Well, you know what? I'm going to need additional set of brackets here. This is all over 0.065 divided by 12. Oops, okay, hold on. There's a syntax error here somewhere. Okay, maybe it doesn't calculate it with brackets. Maybe I need more parentheses. Okay, there it is. Okay, so that tells us right there, after 15 years of making your monthly payments, you're going to be left with $56,963 with 52 cents, right? So that's the lump sum payment that they're going to have to send on that date, right, to pay off whatever's remaining on that balance of that house. Okay, so let's go back. 56,963. And I believe the cents, what was it, 53, I think? Yeah. Okay, so that tells us how much is going to be paid off on that date. However, that doesn't answer the initial question, which was how much interest could be saved by paying off the 20,000 year mortgage on a lump sum on that date, right? That doesn't tell us much, okay? So how else can we go about finding how much is this person going to pay over the lifetime of this loan, okay? All right. So let's go about it in the process of what would this person have paid in total if they would have just kept making monthly payments for those 20 years, right? How much would they have actually paid? Well, we know how much they pay monthly. Okay, we know that, well, they would have to do that for 12 times a year and then for a total of 20 years because that was the length of the mortgage, right? So this is 20 years here. Right, so let's see how much these people would have paid in total. 1119 times 12 times 20, right? So these people in total would have ended up paying $268,560, right? Had they just kept making their monthly payments, right, year after year, that's how much they would have ended up paying, right? But remember that the loan for this house was only 150,000, which means if you subtract away the 150,000, okay, this is how much they paid in interest, right? Because the value of the home was only 150,000. Okay, so now we know we're getting close to being able to answer this, right? So had they continued to just make monthly payments, they would have paid a total of $118,560 in interest. which sounds crazy, right? Because your house alone was worth 150,000. So to think that you would pay almost as much as you paid for the house in interest, that's insane, right? Makes you not want to buy a house. Or at least now that I'm looking at the numbers, it doesn't make me want to buy a house. Okay, so now,
Paid off cash, Moses.
huh?
Just paid off cash. I know
I
you got
know,
money.
I know. I need to get like a fat contract, fat teacher contract to help me pay that off. All right. So, okay, so we have these parts, right? We have these parts so far. Okay, so that's how much we would have paid in interest. Okay. But since we stopped at year 15 instead of going all the way to year 20, we are going to send a big lump sum payment of 56,000. By doing so, how much interest are we going to save? Okay, well now we have to do something else. Okay, we have to do something else. So we already know how much interest would have been paid in full. So we know that we're going to have to do a subtraction from that. Okay, we know that this would have been 20 years worth of interest is 118,560. Okay. Now, how much interest was paid in just 15 years, right? How much was paid in just 15 years? Because then that's going to tell us exactly where we stopped paying interest, right? And then the difference is going to be how much we saved, right? So if instead, now let's find out. Okay. Let's try this now. Monthly, kind of similar idea where we are paying 1,119 for 12 times a year, but only for 15 years. Right, let's see what was the total amount paid. Okay, so it was 201,420. Okay. Um, all right, so that's how much was paid, right? These people were making those monthly payments up to year 15. That's how much they've paid so far. But then, right, rather than paying the monthly payments for the next 5 years, they just send all of this money towards the house, right? So what was it that they sent? They sent the 56,963 with 53 cents. So really, what did they pay in total for the home? They paid, we would have to add this back now, 963 with 53 cents. Okay, so okay, so instead, what they really ended up paying for their home was 258,383 with 53 cents. Now, part of that is, remember, part of that is a combination of the payments towards the house and then the payments towards the interest, because during those first 15 years, they were paying monthly interest at a crazy rate, especially the first few years. So if that's how much was paid in total, remember that the house only cost 150,000. So let's subtract 150,000 from here. So how much was actually sent to interest, right? This is our home. How much was paid to the home? But the remaining amount was what was paid to the interest. Right, so this is the 15-year strategy with the lump sum at the end. The total amount that was sent for the home, which included the interest and the home together, was 258,383. But remember to always subtract away what the value of the home actually is, and that's going to tell you how much interest you've actually paid. So in this case, by doing that, right, it's 108,380. with 53 cents. That's the interest of 15 years worth, right? And they're going to save themselves some money because at those last 5 years, they're not sending any monthly payments. So they're not going to have to pay any interest. So then here, let's go back. Right, the 20 years worth of interest would have been 118,560. 15 years worth of interest was 108,383. Was it 83 or 53? 53. Okay, so we can subtract these two amounts, and that's going to tell us how much money was saved doing that 15-year strategy. Okay, so let's go ahead and find out. All right, so it kind of pays off, right? By doing that lump sum payment, you've saved yourself $10,000 over the course of those final 5 years, right? You would have kept making monthly payments. Maybe it would have felt easy, right? Like it's not that much, it's doable, but you're paying off a lot. You're paying a lot of interest in those last 5 years. So if you can save it, go ahead and save it. So then really what we end up saving here is 10,176 with $43, 43 cents. This is saved, right? Interest. And there you go. Right, so kind of a complex problem, right? Because you got to attack it from multiple different ways. You have to find different pieces of information so that then at the end you can put it together. So let's kind of recap what we did. Okay, so first off, right, we're using Josh's idea, right, which tells us that here is a quick way to find out how much you're going to owe if you are making monthly payments after a certain number of years. All we do is we take the future value formula, the one that is going to help us tell us how much our investment has grown into. We're going to reverse it. We're going to subtract the second part of the formula so that we can then find out how those monthly payments are taking deductions from what I owe, right? So month after month, subtracting away bit by bit. Okay, so after 15 years, what you owe on the home is only $56,963. Okay, so we know that. Because we're trying to find out how much interest could be saved by doing this lump sum strategy after 15 years, we first have to find out how much interest we would have paid had we kept going at the regular pace. So that's what we did here, right? Monthly payments for 12 months out of the year times those 20 years. That tells us that we would have paid the $268,560 over the lifetime of the entire loan. However, because your house is only worth $150,000, when you subtract it away, that tells you how much you've paid in interest. Okay, so it's $118,560. So 20 years worth of interest, $118,560. If we try the other strategy, well, we first have to do those monthly payments 12 times a year times 15 years, right? We have to maintain those monthly payments. And that tells us how much we've paid up until then. However, because we know that we still have money left over to pay for the house, that's where we add that leftover quantity of 56,963. That's what we got from the formula above, right? So Josh, his formula, that helps us in this case because we know, okay, this is how much I've paid so far, but I still need to pay off this last amount, those 56,000. So I add that together. That tells me that this is how much the total value of the loan that I have to pay off, that's how much it is. But again, we subtract the 150,000 because that's how much the house is worth. And then that leaves us with the 108,383 that we paid in interest. So even though it is quite a lot, right? $108,000 worth of interest, but it's not as much as 118,000, right? So in the end, right, those 5 years paying it off, not only have you saved yourself interest, but now every month you don't have to make those monthly payments, right? So just imagine, not only did you save that, but think about how much money you're going to have left over that would have gone, that is going to go to your savings instead of having to go to your monthly payment for your mortgage, right? So think of it as like a double win. I save money and then I get to save the money that I'm not sending to the home, right? So this would have been right $67,000 that you get to keep in your pocket, right? And part of that would have been money that would have gone to interest, okay? So there is the benefit of saving up even while you're paying a home to then make big payments towards the home, right? To get rid of it quickly, okay? Are there any questions on this process so far? Okay. All right. So that was enough work for one problem there. Okay. Now the last part is pretty simple because it's just analyzing and using a mortgage loan calculator and understanding what an amortization schedule is. So the amortization schedule shows the amount of each loan payment that is interest, how much is applied to the principal of the mortgage, and then the remaining balance. Okay, so it basically breaks it down for you. This is your payment, this is how much went to interest, this is how much went to your home, and then this is how much is still left for you to pay. Okay, so there is a link down here, right, the source, and then if you type this in, you would be able to go to that same website. Okay, I'll post a link to this in case you want to play around with it. So I'll post it to School of Gene. So let's kind of go over here and kind of see what's going on. So here it is, right? Here's our mortgage calculator. The first thing you would want to set on one of these is how much of the value of the home is. Okay, so let's go with something reasonable, right? I don't know, 350,000. Okay, I guess depending on where you choose to live, that could be a not bad. Not a bad home there. Okay. Okay. So now a couple things to control. Here on the side, you have a down payment. Okay, let's assume right now we don't have down payments to put down. And let's just say that for the length of the loan, we're gonna go with 30, right? So notice how it's automatically estimating what your monthly payment might be. And what's nice about this estimate is that I believe it includes the insurance and the something called PMI, which is something that is additional when you don't have the 20% to put down as a down payment. Okay, so that would be a monthly payment on a home for 350,000. That if you take the loan out for 30 years and you have an interest rate of 4%. Okay, so it kind of shows you how things work. So if you notice that there's three different ways to read the graph, it shows you three different things. First, if you look at the one that's in blue, or it's kind of like a light purple, right, you can see how the remaining balance starts to shrink. And you see how this looks like the curve that we looked at last time. It's not a straight line, it's a downward curve, right? So the balance is coming down, but not at a linear rate. The reason why is because at the beginning, the balance is barely getting chipped away versus towards the end, you're chipping away a lot towards the balance, right? Towards the end of the loan. Okay, so what else? You can also notice how the interest starts to build over time, right? So the interest at first is growing pretty quickly, which is in red, right? So follow the red dot and you can actually see down below how the interest is growing. So by the end, let's say on a home like this, by the end of it, if you pay every monthly payment, you would have paid 181,000 in interest for a house that was worth 300,000, 350,000. Okay. And the principal, this is kind of working in the opposite direction of like the remaining balance. It's basically like how much you've put towards the principal. So that's the green, right? So again, at the beginning, it grows pretty slow, but then about halfway, you start to see it start to climb a little bit faster and a little bit faster. Okay, so it kind of shows you like all three, the balance, the principal, and the interest. So what is an amortization schedule? It's this right here, right? So on the first day, right, on the first day that or the first month, right, that first payment that you're going to make to your home, that first payment is 1970, right, which is the estimated amount, right? So they calculate 1966. They're just going to round it up to 1970. Out of that amount of money, this is what is going to go to your principal, right? 803, but it's going to take 100 or 1166 to go to interest, right? So that's how your payment is going to get broken up. After that, this is what the balance is, right? The remaining balance. So remember, you started at 350,000. So after that first payment, you've gone down to 349,196. Okay. The next month, same thing, right? It's what we did in problem number 3, right? That kind of recursive process, except that this does it for us. So this is the schedule. So this is something that when you buy the home, they'll give to you so that you can see for yourself, well, how much am I paying in principal each month? How much am I paying in interest? Okay. And this goes on, right? Assuming that we bought it today, right? May 21st. That means that you wouldn't pay this off for another 30 years. So it does it for the next 30 years until you finally pay it off, right? And then you have a remaining balance of 0. Okay. So how much did you really pay for everything? For a house that was worth 350,000, you paid 531,000. Okay. Why? Because of the interest, right? The interest added up to be 181,000. Okay. And so that's how these schedules work. Okay. So it tells you the breakdown of where your money is going. How much goes to principal? How much goes to interest? Okay. All right. So real quick, determine the balance of the mortgage after 60 monthly payments and then after 120 monthly payments. Okay, so this is something kind of easy. I think we'll leave this to next time, because then we can play around with some of the interest rates, some of the terms, and you can start to see how it's beneficial sometimes to get a shorter term loan. Right, getting the 30 years does make it more affordable for you because it divides payments up over 30 years, but you pay a lot more in interest. So I want to spend some time on that next week when I see you guys, and we'll think a little bit more in detail, and then we can probably use this calculator to solve a couple more problems. All right. So hopefully next Tuesday we might be able to finish up. If not, we'll finish up next Thursday. Okay. But I think that's